Hi folks, Jack Summers, Smoky Mountain Scientific, and today what I'm going to do is show you how, show you the guts of the Wheatrometer spectrometer. So in the past I have shown assemblies, but it occurred to me that if I show you how to disassemble it, you get the same information, but you don't see me screwing around trying to get the screws to line up. So hopefully this will be a little better. All right. Okay, so this is the spectrometer we're talking about. It's printed in this orange plastic, and it's got black parts. The body is orange, the other parts are black. Right now we have a fiber optic connected with an SMA905 connector, and I'm just going to unscrew that and take it apart. And I'll put the lid on that thing so it doesn't screw up, don't get it dirty. Set that aside. Okay, so the SMA905 connector is something that we will sell, and I'll tell you how to get that at some point. You can also use a cell holder, a cuvette holder, and this is a 3D printed cuvette holder that we've made that bolts on the front instead of the fiber optic connector. Okay, so that's another option you have. You'll notice that all of our assembly and disassembly happens with a Phillips head screwdriver. Okay, so let's take the lid off this thing and see what we got. So right now there are 4 screw holes, but I've only put 2 screws in it to make it a little quicker to come apart. Okay, then the lid we can just take off like that, and you see what we have. On this side we have the slit. Light comes in through the slit, comes over here to the collimating mirror. You can see the collimating mirrors down in there. Reflects off to hit the grating, and then the focusing mirror, and over here is the charge couple device. Okay, so I guess we'll start taking off the fiber optic coupler. So that comes off with 4 screws. The screws are longer than they have to be. I think that 3/8 of an inch would be a good size for these, and right now what I've got on there is 1/2 inch, and it's taking a little longer than it absolutely has to be. And of course, if I were trying to line everything up, this video would just take longer, so that's why we're taking it apart instead of putting it together. Okay, so there is our slit, our optical slit. You can see that right in the center here, there's a little line where the light comes through. Okay, then we have our 3D printed plastic parts. We need to take this piece off. That's connected using number 2 sheet metal screws. Everything else is number 4 sheet metal screws. Might be better to use the number 2s. They're not as large. They're not as I don't know. Our current design gives kind of a industrial toy kind of look to it. Didn't get those completely out, so let's do that. And but one just hanging there. Okay, let go. Alright, so beneath the SMA 905 coupler we have a little spacer. It's a thin piece of 3D printed plastic, and beneath that, if we can get it off, it didn't come off, there it is. Okay, and underneath that is a 5mm, what is that called, ball lens. Okay, so to put this thing back together, you would drop the lens in there, It's a quartz lens, so it'll not. Well, it's actually a fused silica lens, so it's not going to absorb in the ultraviolet. Shouldn't anyway. And our assembly method just is the opposite of the disassembly method. You put screws on there, you screw them in. And I'll put 2 of those in there just to keep the whole thing from flying apart. I don't want to lose those, lose the ball lens because it tends to roll freely. And we don't want to lose things. Why is that not going in? Come on, there we go. There we go. All right. All right, so that is the fiber connector and the slit. Let's see what else we have on this thing. Okay, so on this end we have a micro USB cable, and that connects to the Teensy development board. So this is programmable using your friendly Arduino code, Arduino environment. Taking those, there's this electronics lid part, and that looks like a 1/2-inch screw as well. We see the Teensy right underneath. That's held in with, well, it's connected using using headers to a board underneath it. You see there's this green grounding cable. I was using that for diagnostics. That's not something that that I will put on any other board unless I have issues with it. It's nice to be able to hook up an oscilloscope or a multimeter and do some testing on it, but not necessary. Okay, let's get those things off. Again, number 4 sheet metal screws connect this whole thing. That's the electronics housing, and here is the electronics. Okay, the electronics consist of this Teensy development board. It's got the headers screwed on there. Just bought all that stuff from PJRC. The amplifier and ADC board is this purple one. Got a bunch of those on order. And on the other side of this, we have a TCD 1304 charge couple device. I just bent one of the pins on. Alright, so that'll bend back. Hopefully it'll all work. Of course it'll work because these are not connected. Alright, so this guy, when you get it, you might have to solder the headers on. There's a 14-pin, 2 14-pin headers on the top side. There are 3 2-pin headers and a 5-pin header that connect the what's this called, the CCD. CCD has a little notch here that goes with the little drawing of a notch that's on this side of the board. So let's hook that back together. Alright, that all just slides in like that. Snaps in place, just like Legos, you know. Alright, this guy here, there is a little drawing, a little whatever it's called, lines indicating that is where this USB connector goes. If you don't see the lines, you line up the USB connector with where it says Weetrometer Teensy and just push it down in. Okay, that drops in with the USB connector pointing toward the back side, away from where the slit was. What else do we have here? Let's see. On this side we have the focusing mirror. The focusing mirror is the 20 millimeter by 50 millimeter mirror, and it is also attached with number 4 sheet metal screws. It's got 3 of them. Okay. The focusing mirror is held in place by a 3D printed, what is it called? 3D printed mirror mount. And there is a piece of black foam that goes behind the mirror. The mirror itself is quite okay. Well, I guess that's good that it didn't just drop out. Okay, there's the mirror. To put this together, you put these. Those look like the right size. 1/2 inch seems like a good number there. You put those into the mirror mount. You drop the mirror in there. You get it to align. Probably be a good idea to align it before you screw it in. But you get it screwed in there. You throw in the black black foam. You wonder why it's not lining up. Anyway, we're not going to worry too much about how that goes together at this point. We're taking it apart, right? On the other end over here, this is the collimating mirror. Collimating mirror is going to be less of a pain in the butt, but I'm hoping. All right, once again, number 4 sheet metal screws and the, whatever that's called, the Phillips head screwdriver. And it all comes apart. Should all come apart pretty easily. Goes together reasonably easily. Okay. There's our circular collimating mirror. It has 100 millimeter focal length. Last parts are the grating here, right? And this model has it's supposed to have a 1200 line per millimeter grating and gives a good view of the visible spectrum. But this one has a 600 millimeter per lines per millimeter grating. And I'm not sure why that ended up in my box of things that I thought were otherwise. Alright, so there's the grating, and this is the outer grating mount. Here's the inner grating mount. And the grating itself, you have to look and see where that arrow is pointing. That arrow should point away from the focusing mirror and be sandwiched together in such a way that the light path out toward the focusing mirror is not obstructed. Okay? Alright, so that is my little demo of taking this thing apart. I'm going to put that screw in just so that I don't lose stuff. Losing stuff is kind of the bane of my existence, but that's life. Alright, so I hope that this has been somewhat informative. Hasn't taken very long. You can see how when I get my screws all aligned, everything goes together pretty fast and simply. We will eventually get the right size for the screws, and we'll make sure that we have the correct gratings, and hopefully everything will be all good and easily reproduced when we make this stuff available. Okay, so we have a body that's 3D printed. We have a number of other mounts that are 3D printed, one for each mirror. There's 2 mirrors, one for the slit, 2 for the grating here, and a couple of electronics part holders, and that's the 3D printed parts. Alright, I hope this has been helpful, and that's what we got.